Hi, I'm James Malone. Today I'm here to talk about what's new in open source data processing on Google Cloud. So today I want to talk about six things. I want to talk about who we are, and then I want to talk about a few key releases that are really exciting for us. Dataproc Metastore, Dataproc Hub, some of our open source updates, a few new features, and then how you can get started using our managed open source services on Google Cloud. First, I want to talk about open data analytics. We're a group that's passionate about combining Google infrastructure with the best of Google Cloud. We think that open source represents, in many cases, the best of software. It's community driven, it moves quickly, it really pushes the envelope of what's possible. We also think that Google Cloud can run infrastructure like nobody else. So we're really interested in combining the power of open source and the power of Google's infrastructure to create managed services so you can use managed open source on Google Cloud. We think that open source should be efficient, secure, and accessible. Over the last year, we've released over 40 releases. And the reason I bring this up is we are very interested in keeping up with the open source community and all of the new releases. But we also want our customers to rapidly have the latest and greatest in both open source and also Google Cloud Platform features, things like VPC service controls. We think the faster that we can enable our customers, the faster they have access to the best of both open source and Google Cloud. One of our big new releases that I'm really excited to talk to you about today is the Dataproc Metastore. So I'm going to give you an overview of what the Dataproc Metastore is and why we have developed the Dataproc Metastore. The Dataproc Metastore is essentially a managed Apache Hive Metastore. So I want to start out with why the Hive Metastore is such a big deal, because that drove why we developed a managed Metastore service in the first place. The Apache Hive Metastore is really, as far as we see it, the open standard for data lakes. There's a lot of tooling that depends on the Hive Metastore, things like Hive, Presto, Spark, Impala, Hootie, and many more. There's also an emerging set of open source that uses the Hive Metastore in data lakes, things like Iceberg and Delta Lake. The Hive Metastore integrates with a lot of open source that people use as part of a data lake, things like Kerberos, Ranger, Atlas. And the Metastore can understand or represent data that's in many different places, things like Hadoop clusters, cloud storage, BigQuery, other cloud providers, block storage, Elasticsearch clusters, Kafka clusters, and so on. So to put it simply, the Hive Metastore is the central point for open data lakes, and it's a critical path for any data lake which is built at least partially on open source. So it's very important that Hive Metastore is usable and reliable. So we developed the Dataproc Metastore. We recently announced that it's in alpha public availability, and the goal was to have a fully managed, highly available, and open source native Apache Hive Metastore. We want to provide an Apache Hive Metastore service that removes all of the barriers for using both the Hive Metastore and the tooling around the Hive Metastore. From our point of view, if we give you the best managed Spark or Flink service, it really falls apart without a well-managed Hive Metastore, which is why we developed the Dataproc Metastore. It's also really important, and I'm going to underscore this point again, that the Dataproc Metastore is open source native. We don't want to limit what people can do with the Apache Hive Metastore. We want the Hive Metastore to be highly usable, and often Hive Metastore sounds simple, but their actual maintenance and operation can be quite complicated. Throughout our design of the Dataproc Metastore, we focused on simplified management. This is an example of creating a new Dataproc Metastore. In this case, you can see the creation screen for just creating a Metastore. You can see that we only require a few simple options, things like a name, the Metastore version, where you want to create that Metastore, whether you want Kerberos to be enabled or not. This makes getting started with the Hive Metastore very, very easy, essentially one click. Likewise, we want the Hive Metastore to be very compatible. So if you have an existing Hive Metastore, we want it to be very easy for you to bring your data to the Dataproc Metastore. In this example, we have the import functionality. This allows you to take an existing Hive Metastore and import it into a Dataproc Metastore. So it should be easy to create a new Metastore and play around with the Hive Metastore and its tooling if you're a new user, or if you're already deeply embedded and invested in the Hive Metastore ecosystem, it should be very easy to migrate to use the Dataproc Metastore. Throughout the design and implementation of the Dataproc Metastore, we've wanted to create a service which is flexible, integrated, and reliable. In terms of flexibility, as you're using the Dataproc Metastore, if you want to, for example, scale your Metastore up because you have more users or you have added more tooling which uses the Hive Metastore, we want it to be very easy for you to manage that Metastore, the resources, who can control, who has access to the Metastore, how it works, things like that. We also want that Metastore to be integrated. As I mentioned previously, the Hive Metastore sits at the center of an open data ecosystem. So it's really important that the Metastore works with a lot of things out of the box. As an example, we've worked with Calibra and Qubel to make sure that they work out of the box with the Dataproc Metastore. There are two examples, but they showcase that we're very focused on making sure that the Dataproc Metastore is open and integrated. Metastores are also very difficult to run because they are a critical path in your ecosystem. If the Metastore goes down, often many things break. So it's important to us that the Dataproc Metastore is reliable. And from the ground up, we've designed the Dataproc Metastore so it's highly reliable. There's another really interesting feature which I want to showcase upfront today, and that is the Dataproc Hub. Let's start with two personas. On one hand, you have a data scientist, and on the other, you have an IT administrator. And say that both of these people or personas work for the same organization. They have different needs. The data scientist wants to create notebooks that are building blocks. They want to create models. They want to tinker and experiment and explore with data. And often data scientists want to do this in a way that's unimpeded. So they want to be able to create a notebook and use tooling. And often data scientists are preferential to frameworks and tooling. So they just want to get started and hands-on with data. On the other, you have IT administrators who are concerned about things like making sure that code is production ready and productionized properly. They also care about costs and controls and security, things that the data scientists might not have front and center in mind when they want to get started with a notebook. What this usually means is that when a data scientist wants to create a notebook, create a model, and then get something in production, it can take weeks, if not months, and require a lot of steps in between. We think that things should be much, much easier. The data scientist should be able to create a notebook and then take that notebook and have it turn into production-ready code or productionalize their notebook as easily as possible. In essence, notebooks should be easy, configurable, and all in one place. There shouldn't be a lot of steps, there shouldn't be a lot of friction, and there shouldn't be a lot of organizational frustration in trying to both enable notebooks and also control them at the same time. So we built Dataproc Hub. We recently announced Dataproc Hub in open beta, and Dataproc Hub is built in conjunction with the AI Platform Notebooks functionality on Google Cloud Platform. Ultimately, what this means is that we are bringing data scientists and IT administrators together, and we're also bringing notebooks together with AI platform tools and Dataproc. As a result, data scientists can easily create notebooks. They can choose their favorite open source toolkits and frameworks, and they can use advanced features on Google Cloud Platform on Dataproc clusters, things like GPUs or SSDs if they have workloads that are IOPS performant. What this means for IT administrators is that they can predefine who can do what with notebooks, what the size and shape of Dataproc clusters looks like, what features are automatically enabled or disallowed. It also makes it very easy for these IT administrators to see exactly who's using notebooks and then take what's being done and productionalize it very, very easily. The IT administrator story is really important to us as we think about notebook use. And as the first, it's an optional, but as a first step, an IT administrator can predefine who can do what with Dataproc Hub. Specifically, what this means is an IT administrator can predefine what size, shape, location, and features are used in a Dataproc cluster that powers a Dataproc Hub notebook. That way, once somebody gets their Jupyter-based Dataproc Hub notebook, all of the constraints are automatically applied for the cluster that runs and powers that notebook. In this example, we have a YAML-based cluster configuration that specifies an idle configuration. So in this case, the cluster would be deleted if it was idle for more than 7,200 seconds. An IT administrator can use this configuration as a template for clusters that are then used for Dataproc Hub notebooks. So if a cluster is idle, it automatically gets deleted. And this showcases how we're trying to bring both data scientists and IT administrators together with Dataproc Hub. Ultimately, the flow of using a notebook with Dataproc Hub and AI Platform notebooks should be fairly easy. The data scientist can go look for examples or snippets in AI Notebooks platform, or go directly to Dataproc Hub to create new notebooks or reuse existing notebooks. Then they can use that notebook and Dataproc or BigQuery to prepare, process, and create models, data sets. All the while, the IT administrator can see who's doing what with notebooks. They can pre-configure the boundaries on what notebooks can do and the clusters that underlie them. And then they can do things like schedule and manage notebooks that have already been created by Dataproc Hub. Ultimately, this is showcasing that it can be a frictionless process between data scientists and IT administrators. It also makes it very easy to create Dataproc clusters with Jupyter-based Dataproc Hub notebooks for data scientists. So there's fewer hoops to jump through when you want to do data science. So in this case, I'm going to show you what a quick demonstration of Dataproc Hub looks like to show you why it's really easy to get started with Dataproc Hub to do data science with open source tools. So in this example, I am a data scientist and I want to maybe use Spark and BigQuery. So I know I can go to AI Hub and find some examples for common situations. In this case, I'm going to see if there's an example for how to use Spark with BigQuery together. So I search for BigQuery here, and I will get a list of results. And in the results, I can see that there is indeed a quick example showing how to use Spark with BigQuery. This is using the Spark BigQuery connector that's provided on Dataproc. I then can take that example and open it in the AI Platform notebooks. And I already have a pre-configured workbench that an IT administrator has pre-configured for me. I then sign in. So Dataproc Hub does perform the authorization and authentication checks. And you can see that the cluster that is behind this notebook has been already pre-configured by the IT administrator. So as a data scientist, all I need to do is just click start. This creates the notebook. It also creates the cluster that powers the notebook behind the scenes. You can see in this example that all the data scientists had to do was click start, and they got the notebook and the cluster. They don't have to think about configuration. They don't have to think about networking plumbing or cluster options. The data scientist doesn't even necessarily have to know what Dataproc is. All they did was create a notebook and get started. Beyond Dataproc Hub, I want to talk through some of the really important open source updates that we've provided on Dataproc in the last several months. We make it a point to keep up with the latest and greatest in open source, and we're really passionate about bringing new open source developments to you in Dataproc as a managed service. One of the big advancements that I want to showcase is Dataproc 2, which just entered public preview. Dataproc 2 includes some significant upgrades in the default components that we install on Dataproc clusters. What this means is you get Hadoop 3, Spark 3, Hive 3.1, Java 11, and several other upgrades to components that we put on clusters by default. We keep the number of components that we install by default somewhat slimmed down so you have efficient clusters, and we narrow the installs down to the most used components. But there's still a whole set of things you can install on Dataproc clusters through initialization actions, custom images, optional components, and other means. These optional installs have also been updated in Dataproc Image 2. So it includes things like Apache Flink, updates to Apache HBase, Druid, Presto, and others. So Dataproc 2 is a brand new image line in Dataproc designed to bring the Hadoop 3 and Spark 3 ecosystem to you. I specifically want to talk about Spark 3 because Spark 3 includes a number of really interesting and important updates that we're excited both to bring you in Dataproc, and we're very interested in seeing how we can bring these functionalities and improvements to future Dataproc features. So the theme for Spark 3 was performance, and there's 3 good examples of what that means for you in terms of performance in Spark 3. First, Spark 3 includes better adaptive query support, so Spark can optimize a query plan while things are executing. Spark 3 also has dynamic partition pruning, so unnecessary scans are avoided in queries that could look like data warehouse queries. So again, faster querying. Spark 3 also has improved GPU support, and we're really excited because we think there's a future where Spark 3 could run entirely on GPUs, both for data science and potentially just general data processing. So we're very interested in seeing what the future holds for Spark and GPUs. There's also a lot of advancements for Spark running on Kubernetes. I'll talk about it in just a bit, but Dataproc has a flavor which allows you to run Spark on Kubernetes clusters that are managed by Dataproc. So we're very excited to see new advancements in Kubernetes and Spark because it will only make both the Spark community better, but also makes Dataproc a much more interesting product from a Kubernetes perspective. I mentioned GPUs before, but this is something that's really, really exciting to us. And we've worked closely with NVIDIA to make sure that GPUs work well in Spark and also that GPUs work well on GCP and Dataproc clusters. So you can create Dataproc clusters with NVIDIA GPUs today. We've also worked with NVIDIA on things like the Rapids frameworks to make sure that you can do really high performance data processing and data science on Dataproc clusters. If you're interested in using Spark 3 with GPUs, I would highly encourage you to look at the documentation on the Dataproc site and also the Rapids framework. We think this is a really interesting avenue for Spark and open source in the long term to run on GPUs. It's very easy to get started with Dataproc 2 today. All you need to do is specify that you want to run the preview of Dataproc. So this is an example of a Cloud SDK command or a gcloud that specifies the preview image. I also want to call out how easy it is to use different sets of open source components on Dataproc clusters. You don't have to think about upgrading one whole cluster to new versions of Spark or Hadoop. If you want to try out a new version of Spark, in this case Spark 3, create a very small new cluster and use the preview image. Try a job out, try some of the new features out, then you can delete the cluster when you're done. Dataproc imaging is a subtle feature, but makes it very easy and interesting to try out different sets and versions of open source components without fear of breaking clusters that are running production or high value jobs. There's also a whole set of new Dataproc features that I want to run you through as well. As I mentioned, we have a flavor of Dataproc which runs on Kubernetes. We recently announced Dataproc on Kubernetes Engine clusters in beta. What this means is that you can run Spark jobs with Dataproc on GKE clusters. We are really excited about the future of running open source on Kubernetes clusters. I'll give you 3 examples of why. One, we think that it allows better resource management. So you can have multiple things running on one cluster and be a little bit more sure that resources are being balanced and managed properly. It also allows you to take one Kubernetes cluster and run open source data processing with something like a web application, if you were so inclined. It also potentially allows for better job isolation. And as customers get better resource management, job isolation is something that goes hand in hand. We're also really interested in both seeing and helping these open source frameworks and toolkits work with some of the more advanced and interesting features on Kubernetes, things like auto scaling, node healing, and the like, because that allows for more dynamic clusters over time. The Dataproc team has been involved in getting both Spark and Flink working on Kubernetes. Last year, we released both an operator for Spark and Kubernetes. Because it's a common question, I do want to call out that we will support both Yarn and Kubernetes well into the future of Dataproc. We're not making a wholesale decision to switch from one to the other. We see customers over the next several years will want to use both for different reasons. And we have a plan to support both Yarn and Kubernetes well into the future. Another feature that I'm really excited to mention is Dataproc Flex Mode. I'll explain Flex Mode through a problem with both scaling and virtual machines. When you're trying to scale down, you may hold on to a node or a set of nodes because they have intermediate data, they've finished processing, they're just holding on to something that they can't get rid of, but otherwise you would get rid of the node. Likewise, with preemptibles, you may have a node that's finished processing or reached a state where it can checkpoint, but the node is preempted. In both cases, if you removed the node, you would lose the data. Flex Mode is a stateful data store that allows you to store stateful data such as MapReduce shuffle data in HDFS on the cluster. This makes clusters more flexible because you can add and remove clusters much more easily without interrupting your job. So in my example, if you wanted to scale down, once the node's done computing, it can put all of its data in Flex Pool, and then the node can simply be auto-scaled down. Likewise, if you lose a preemptible VM that's finished processing, that preemptible VM has already put its data in the Flex Pool, so its preemption presents no risk to your job. Flex Mode should allow better auto-scaling and also should allow you to use more preemptibles in your Dataproc clusters, which again means greater flexibility and cost optimization. There's two new security features which we're adding to the pile of pre-existing Dataproc security features. So Dataproc already allows you to use security features such as Ranger, customer managed and customer supplied encryption keys, Kerberos, VPC service controls, our component gateway, which allows you to access web UIs with no networking, but still provides authorization. All of these are great, but customers have told us they want more security, which we've been squarely focused on. And these are two of multiple new security features, which you'll see in the future. One of the security features is secure extensions for notebooks. What this means is that you can give somebody a notebook, and that someone, or the data scientist, for example, their credentials will be used for execution of the job and to communicate with whatever services that job connects with. So for example, if I am a data scientist and I interact with cloud storage, my data scientist individual credentials will be used to go talk to cloud storage instead of a service account. And this brings better per user isolation and security to notebooks. A second feature that we recently announced was shielded VMs. So if you're using Dataproc clusters with Ubuntu 18 or Debian 10, you can use shielded VMs. Again, these are two new out of future security improvements that you'll continue to see in Dataproc to make sure that customers have all of the security features, both that they might want, but also that we could potentially offer as a cloud provider. I want to finally mention something that doesn't get a lot of attention, but is a kind of a continual feature in Dataproc, and that's additional compute flexibility. Every time there's a new region or a new VM type or a new accelerator, we try to wire those through to Dataproc as quickly as possible. What this means is you get new levers for cost and speed optimization. In this example, say that you had a workload which was performance insensitive and you just wanted to lower your cost. You could use E2 machine types to lower your cost relative to maybe you are running on N1 standard 4s. You can see in the table all of the VMs kind of look and feel the same, but the cost is different. This is an example of how additional compute flexibility can give you some really powerful levers to speed things up or to optimize costs, depending on your needs. Finally, I want to talk about how you can get started with Dataproc. The best place to get started with Dataproc is our documentation on the Google Cloud site. We also have a set of tutorials on the Dataproc site, things like using Spark with BigQuery or creating clusters to run Presto. So you should be able to run through those tutorials to understand Dataproc and some of the open source tooling pretty quickly. If you're brand new to Google Cloud, I really encourage you to take a look at the free trial for Google Cloud Platform to get started with both Google Cloud and also Dataproc. If you're curious about Dataproc, you're an existing Dataproc customer and want to know more or participate, we have a Stack Overflow tag, Google Cloud Dataproc, which you can use to find questions and ask new questions. Often you'll see the Dataproc engineering team trying to help customers and Stack Overflow users. We also have a Google group, Cloud Dataproc Discuss, and a feedback email list. And please do send us your feedback and thoughts. It's customers that largely influence and help drive our roadmap. So we are passionate on hearing and responding to our customers and whatever needs you may have. With that, I want to thank you very much for your time and have a great day.